There are many different ways to charge your electric car's battery pack. Being faced with regular and fast charging methods and various connector types can be a little daunting at first. But in fact, it is much more straightforward than it first appears. Essentially, it comes down to two main considerations: where you decide to charge and how fast you decide to charge. These are interconnected, and the charging speed will depend on which EV you own, its battery capacity, and what sort of charging system you use. For charging EVs, DC or AC systems can be used. Different current and voltage configurations for charging are generally denoted as levels. The time required for a full charge depends on the level being employed. Wireless charging has also been tested and researched for quite a long time, and it has different configurations as well. So, in this video, we are discussing different charging methods of an electric car, like AC charging, DC charging, charging modes, wireless charging, battery swap, and solar-powered charging. Let's start with AC charging system. The AC charging system provides an AC supply converted into DC to charge the batteries. This system needs an AC-DC converter. According to the SAE EV AC charging power levels, they can be classified as follows. Level 1. The maximum voltage is 120 volts, and the current can be 12 amps or 16 amps, depending on the circuit ratings. This system can be used with standard 110 volts household outlets without requiring any special arrangement, using onboard chargers. Charging a small EV with this arrangement can take 0.5 to 12.5 hours. These characteristics make this system suitable for overnight charging. Level 2. Level 2 charging uses a direct connection to the grid through an electric vehicle service equipment, and then it transferred to the electric vehicle to charge the battery. Maximum system ratings are 240 volts, 60 amps, and 14.4 kilowatts. An onboard charger is used for this system, and it is also used as a primary charging method for EVs. Level 3. This system uses a permanently wired supply dedicated to EV charging with power ratings greater than 14.4 kilowatts. Fast chargers, which recharge an average EV battery pack in no more than 30 minutes, can be considered level 3 chargers. And now let's take a look at different modes of electric vehicle charging. In electric vehicle, there are 4 different types of charging modes. In Mode 1, it plugs into a household AC socket. This mode refers to charging from a standard power outlet with a simple extension cord without any safety measures. With this mode, the EV is directly connected to a household socket. The maximum current of this mode is 16 amps, and its voltage should not exceed 250 volts in a single-phase system and 480 volts in the case of a 3-phase network. Local standards may be more stringent. Due to this power limitation, charging time takes several hours. Mode 1 is the simplest possible charging mode and does not support communication between the EV and the charge point. This charging mode is prohibited or restricted in many countries. In Mode 2, it plugs into a standard household AC outlet and includes those safety features in its in-cable control box. Unlike Mode 1, this mode requires a specific safety system between the point of connection to the electrical network and the car in charge. The system is placed on the control box charging cable and typically installed on portable chargers. The maximum current of this mode is 32 amps, and its maximum voltage should be at most 250 volts single-phase or 480 volts three-phase. Mode 2 can be used with both household and industrial sockets. In Mode 3, it plugs into a wall box or charging station for an AC charge, and it does not include an ICCB. This mode utilizes a dedicated DV service equipment along with the EV onboard charger. The AC current from the charging station is applied to the onboard circuitry to charge the battery. This mode requires that the vehicle is charged through a power supply system permanently connected to the electrical network. The control box is integrated directly into the dedicated charging point. Mode 3 usually allows charging up to 32 amps and 250 volts in single phase, while up to 32 amps and 480 volts in three-phase. Mode 4. Direct current connection for fast charging. In this mode, EV is connected to the main power grid through an external charger. It is the only charging mode that provides direct current. This mode can provide 600 volts DC with a maximum current of 400 amps. The high power level involved in this mode mandates a higher level of communication and stricter safety features. DC charging. DC systems require dedicated wiring and installations and can be mounted in garages or charging stations. They have more power than AC system and can charge EVs faster. As the output is DC, the voltage has to be changed for different vehicles to suit the battery packs. Modern stations can do it automatically. All DC charging systems has a permanently connected DV service equipment that incorporates the charger. Their classification is done depending on the power levels they supply to the battery. In level 1, the rated voltage is 450 volts with 80 amps of current. The system is capable of providing power up to 36 kilowatts. Level 2 has the same voltage rating as the Level 1 system. The current rating is increased to 200 amps and the power to 90 kilowatts. In Level 3, voltage is rated to 600 volts. Maximum current is 400 amps with a power rating of 240 kilowatts. And now let's take a look at other charging methods of an electric vehicle. Wireless charging. Inductive or wireless charging uses an electromagnetic field to transfer energy between an electric car and a charging pad through electromagnetic induction instead of a plug and socket connection. Based on the application, wireless charging systems for EVs can be distinguished into two categories. They are static charging and dynamic charging. The main idea behind static charging is the use of two electromagnetically linked coils. The primary coil is placed on the road surface in a pad-like construction linked to the electricity network. The secondary coil is placed on the vehicle along with additional power converters and their circuitries, ideally on the bottom or top of the car. Here, a very high frequency AC is transmitted from the transmitter coil. The received energy is converted from AC to DC using the power converter and is transferred to the battery bank. For safety measurements, the receiver coil is enclosed with a battery management system and power control with a wireless communication network to receive feedback from the primary side. The charging duration of an electric vehicle depends on its charging pad sizes, power supply level, and distance or air gap between the transmitter and the receiver. The distance between these two coils is approximately 150 to 300 millimeters. The advantages of static charging method is that it is convenience. It can be well suited for mass transit applications, where it can be used at parking areas of shopping malls, garages, commercial buildings, etc. The disadvantage of this method are high investment, limited space and weight of charge pads, misalignment tolerance between the vehicle and the charging pad, power losses and relatively lower efficiency than conductive charging, and electromagnetic radiation exposure. Dynamic charging. The other way to charge a car wirelessly is by dynamic charging method. In this type of wireless charging system, the battery size is reduced and vehicles are charged while in motion. This uses the same technological principles as stationary wireless charging, but the charge points are embedded in the road networks, so drivers can top up their cars as they drive. In this system, the transmitter is enclosed with a primary charging pad installed beneath the road's concrete along the pathway with high-frequency AC along with its circuitries. The receiver, held with a secondary coil, is placed below the front of the vehicle with a power converter and battery management system. This converts high-frequency AC into DC and charges the battery bank. The coils emit an electromagnetic field that is picked up by vehicles driving over them and converted into electricity to charge the cars. This would result in less stationary charging, as vehicles can travel longer distances while not losing charge when driving. So far, dynamic inductive charging is still in the experimental stage because there are many challenges to standardizing it. The advantages of this method is unlimited mobility and no recharging hassles. One technology for slow and high-speed charging. It is applicable to all types of vehicles. And smaller battery size. The disadvantage are the high cost of investment. Foreign objects, coil structure changes, and coil misalignment on the road. And applicability of different car types and universal coil type selection. Battery swapping. Under battery swapping, EV users replace the discharged batteries with charged ones at the swap stations. It helps to solve the problem of setting up charging stations and also reduces the range anxiety of the drivers. Apart from this, battery leasing can help EV consumers to save on the cost of purchasing a battery. In this case, you can continue driving after a few minutes. The prerequisite for this concept would be that the vehicle manufacturer must install standardized rechargeable batteries at standardized positions in the vehicle. However, standardization would only be possible due to the different vehicle types and uses. And now, let's take a look at how long does it take to charge an electric car. Think of the battery pack size as the same as the size of a petrol or diesel car fuel tank. As EVs have different size battery packs, EV chargers charge at different speeds. Think of this the same way you would the rate at which petrol flows from the petrol pump. EVs can't charge as quickly as this, but the principle is the same. The charging time can be roughly calculated as the ratio between the electric vehicle battery capacity and the charging power. The charging power is limited to the power the charging station can deliver and that which the electrical vehicle can accept. For example, an electric vehicle with 40 kWh battery set and a 6.6 kilowatts onboard charger for AC charging, the estimated full charging time for different charging stations is as follows. 11 hours for a home charging station of 3.7 kilowatts, 6 hours and 30 minutes for AC charging station of 11 kilowatts, 50 minutes for DC fast charging station of 50 kilowatts, and 10 minutes for DC ultra-fast charging station of 250 kilowatts. You have to note that this formula provides a rough estimation. The actual charging time is usually longer for the following reasons. Number 1. Size of the battery. The bigger your vehicle's battery capacity, the longer it will take to charge. State of the battery. If you are charging from empty, it will take longer to charge than if you are topping up from 50%. Max charging rate of vehicle. You can only charge a vehicle's battery at the maximum charge rate the vehicle can accept. For example, if your vehicle's max charge rate is 7 kilowatts, you won't charge any faster by using a 22 kilowatts charge point. Max charging rate of charge point. The time it takes to charge will also be limited by the max charging rate of the charge point you are using. For example, even if your vehicle can charge at 11 kilowatts, it will only charge at 7 kilowatts on a 7 kilowatts charge point. Environmental factors. A colder ambient temperature can take slightly longer to charge, mainly when using a rapid charger. Colder temperatures also mean vehicles are less efficient, so fewer miles are added per time charging. The charging speed profile is not linear. Electric vehicles are not continuously charged at maximum power. In particular, DC charging will charge very fast until the battery reaches 80% to 90% of its capacity and slows down significantly for the remaining 10 to 20%. Solar-powered charging. The term solar-powered vehicle generally describes a vehicle with solar cells integrated into its design, known as solar electric vehicles. Solar-powered vehicles use photovoltaic cells to convert energy from sunlight into electricity. To know more about this charging method, check out this video. So, what do you think about these charging methods? Which one do you prefer the most? Let me know in the comments, and thanks for watching.